which is... In previous lessons we have learned about disproportionality analysis, which is the most common approach to statistical signal detection. Although disproportionality analysis can be varied beyond what we have covered here to make it even more useful, in our experience an even better idea is to complement disproportionality analysis with entirely different aspects of strength of evidence. This makes sense. If you think back to the modules on signal detection and causality assessment, there are lots of different factors that have to be considered in the clinical assessment step of signal detection, and some of those factors are relevant to use also in statistical signal detection. After all, disproportionality analysis just comes down to counting reports based on the presence of drugs and events, and it disregards lots of potentially useful information that may be available in those reports. In this lesson I will present a few additional aspects of strength of evidence to open up your eyes to this possibility. The examples I will show all relate to Bradford Hill's viewpoints on causality, often called criteria, that have also been introduced in earlier modules on signal detection and causality assessment. For example, disproportionality analysis itself measures the correlation in the database between the reporting on a drug and the reporting on an event, and is therefore related to the Bradford Hill criterion of strength of association. Now, consider instead how reports are distributed in time in geography, and specifically compare a situation where all or nearly all reports on a drug-event combination originate from the same place at around the same time, to another situation where there is considerable spread. Unless there are obvious explanations for lack of spread, we should be more confident in a causal link if there is spread, because those reports correspond to very likely independent observations of the same thing. And this is the main idea of the Bradford Hill criterion of consistency. Whether the spread is large or small is something that we can analyze statistically, both in the context of broad database screening or as support to the clinical assessment of a specific drug-event combination. Note that this aspect is entirely different from disproportionality analysis. Reporting can be disproportional with or without a great spread in geography and time. Another strength of evidence aspect that has been used in statistical signal detection is time to onset, which is tightly connected to the Bradford Hill criterion of temporality. For starters, we can try to analyze whether most of the reports in a drug-event combination tend to show a consistent pattern of time to onset. If instead the pattern appears to be entirely random, a causal link is less likely, and this is something that we can analyze statistically. It is also possible to compare time to onset for one drug with a specific event to the observed for other drugs with the same event. This type of comparison is indeed very challenging and requires a lot of statistical reasoning. One of the challenges is that in general, the probability that an adverse event gets reported in the first place goes down as time to onset goes up. There are lots of other strength of evidence aspects that could possibly be used in statistical signal detection. One example is dose relationships, which would correspond to the Bradford criterion of biological gradient. And there is no reason why disproportionality analysis cannot be combined with one or more different aspects of strength of evidence. This is in fact what we're doing in our algorithm VigiRank, which has now been the basis for our own statistical signal detection on Vigibase for several years. We have seen that the use of VigiRank in fact makes signal detection more efficient, which makes sense because the different aspects of strength of evidence that are used correspond to different types of information that is present on the reports. And recently there have also been other algorithms proposed that make use of the same idea of putting different strength of evidence aspects together.